Good afternoon, everybody. Thanks for being here, and thanks for the organizers for having me. My name is Arno. I am the CEO and co-founder of Crystal Sonic. We're a startup based in Phoenix, Arizona, in the semiconductor space, and we're solving a long-standing problem in semiconductor manufacturing, and we use sound to do that, and I'm excited to tell you more about it. Now, I know there's an AI section later, but this has quite a bit to do with AI in the sense that its exponential growth is causing we're seeing some real constraints on the physical side in chip manufacturing. You've all heard of the memory crunch. There's 3D die stacking going on. There's data and photonics applications in chips. These are using advanced materials, as well as the power electronics that go in there using materials like silicon carbide and GaN. These are much more advanced materials than silicon in a number of ways, but they all have something in common, that they use very challenging and complex methods and costly methods to produce. Now, whether it's on the wafering side or the thinning side or the die stacking side, these are basically three-dimensional chips, very complex and very wasteful to do so. Conservatively, about 95% of the chip material, of the wafer material, is actually wasted in the manufacturing process. There's also yield concerns and there's cost concerns with these advanced materials. And our challenge is to reduce that waste, cost, and complexity. And so what we've developed at Crystal Sonic is an acoustic-based method we call sonic liftoff. That is a technology to reuse substrates. We basically split using sound through our patented acoustic separation process. This lowers the cost of production, it cuts waste, and it improves the yield. We've got 10 patents at the moment, continue to file and protect our IP, and we're working with partners on this. A key differentiator in this solution is the ability to yield a very pristine surface. Unlike laser or grinding approaches, you can basically split off a thin layer, a wafer, or a thin layer, and then reuse that underlying substrate, unlike other approaches that are quite old and dirty. We've had quite a bit of external validation in working with our partners, most notably the most recent Lam Capital venture competition we won. We're really grateful to be partners with Lam. This came alongside an investment, and they invited us here to present, and we have a table downstairs as well. This gave us some great exposure, and we're working with them to explore this space a bit more as we go. Quick plug on that, they do have their competition in May coming up in 2026, just in a couple of months. So hope to see some of you there as well. Where are we today? We have a number of pilots ongoing, and we've basically raised seed capital north of $6 million with a number of agencies, including NASA, NSF, DARPA, the DOE, and others, local state of Arizona organizations, as well as strategic corporate venture from Lam, as well as from Valkyrie Venture. So we've given that our foundation. We are working now to accelerate and are negotiating additional pilots currently, and we're opening our next funding round next quarter. So happy to talk more. If anyone's interested, I'll be downstairs today and tomorrow. Thanks for your attention. It's all downhill from here. Thank you.